Hey there YouTube, today we are going to be reviewing this HTC Instruments DM97 multimeter. Before I get into the review, I would like to thank all of my subscribers for subscribing to my channel and helping me reach 100 subscribers. And so let's get into the video. So the HTC Instruments DM97 multimeter cost around 1500 on the Amazon, and before I get into it, I would say yes, it is a very decent multimeter. And when you open it up, you get the multimeter itself, which is in a bubble wrap, and the multimeter is pretty high quality and it's made up of very good rubber casing, and you have probes for mounting probes over here, and it comes with a stand and like this, so you can place it like this for better viewing. Besides the multimeter, we get two high quality probes and a temperature sensor. Beside this is the operational manual and authenticity certification. So this HTC multimeter, hold on a sec. The HTC multimeter is 1500. Yes, that is a bit costly because it is from one of the well-known HTC instruments. Let me zoom it a bit, and it is pretty accurate. The build quality is very good. The probes are also quite good, and they are rated for 1000 volts. And yes, I would definitely depend my life on this multimeter, on this probes actually. So it comes with two clips for the insertion of the probes. So despite this, we have a lot of good functions. For example, the voltage function. And now this is an auto range multimeter, unlike your manual multimeter, which in which you have to select the ranges automatically. This is an auto range, which means you do not have to select the ranges. You just have to select the type of measurement you want to do. For example, over here we have DC, and if I press the select button, it's going to convert into AC voltage. Now from here we can measure the AC voltage. Beside this, we have the continuity, the diode, and the resistance mode. We have to just press this for having diode, then again press for continuity, and then again we have auto range, which is giving us milliohms and megaohms, and then we have the capacitance function. It is always zeroed down to nanofarads, but when wire measuring, it will go up if you're measuring more values than that. Then we have the hertz function, and it can also do the duty cycle. If I press this, it's going to convert into the duty cycle percentage. And then we have the non-contact voltage detection. Then we have the temperature sensor, which is currently showing 18 degrees Celsius. Yes, and then we can select this button to convert it into Fahrenheit. Then we have the HEV, which can be used for measuring the beta of a transistor, whether it be NPN or a PNP transistor. Then we have microamps, AC/DC, and then we have milliamps, and then we have amps. Besides this, the cool feature of this that it has actually a maximum and minimum function, which can be used for the max and the minimum display of the values. Also that we have a hold button. If you can hold it for 2 seconds, it's gonna light up the display. It has a backlight, and then we have the range function. So let's get into how to use the multimeter. So the black lead goes into the COM, and let me untangle this bit. Now this one, which is the red probe, which goes into the voltage, ohm, and the hertz section. Let me move this a bit. Now as you can see, the multimeter is on, and we're gonna hold it for a backlight. Now we have the backlight. Now let me select this. First we're going to measure AC voltage. Now see, we have AC. Now let me pan in a bit. So let me just plug, and one of the main features of this has a voltage protection system, which means if you accidentally function protection system, which means that if you accidentally use the DC function and plug it into an AC outlet, it will not blow up, unlike the usual multimeter. Now let me plug it into the AC outlet. Now you see it will measure. It is showing 236.8 volts SE. Now if you press the max and min, this is the maximum voltage, and then again pressing it, you will get the minimum, which is 236.3 volts minimum. Now for measuring the DC, let me set up a rig. Now one other thing I forgot to mention about this multimeter is that this is a true RMS multimeter. And now I have set up a DC connection of 5 volts. I've connected to my phone charger actually. Now let us put the black in the black, and I'm using jumpers over here. As you can see, it directly went to showing the value, which is 4.87 volts. Now we will check the continuity and diode mode. So let me set it up. Now I have set the meter to continuity mode. As you can see, whenever I touch, whenever there is a continuous circuit, it will beep, and the beep is very loud actually. Now let's check if this jumper is continuous or not, means if it is good or not. So yes, it's going to show some random value of in ohms, and it's going to show the resistivity. So let me bring a few diodes and a potentiometer to check the resistance value. Now over here I've got a 103 10 kilo ohm potentiometer, and I'm going to connect it. I've connected the wiper and one of the leads, and let me zero it down. Now let's set the it's already in yes. Now as you can see, it just went to 120 ohms, and as we increase, we got 3 kilo ohms already, 4 kilo ohms. At a max it's showing 11.37 kilo ohms. That is because I'm using the jumpers and the cable should have some resistance. So that is that function. And besides that, I've got some Zener diodes to test the diodes. Let me connect a bit. So you press the hold button. Now let's check one of the diodes. Now in this multimeter there are grooves in the pin, if you can see it, which makes it quite easy to test components. And we get a value of, as we are connecting it in the proper direction. Let me just see if it is possible to focus or not. Yes. As you can see, we are connecting in the proper direction, and we are getting a reading of 590. And if we reverse that, we will definitely not get a reading. We are not getting a reading. Connecting in reverse, and that is how you check for diodes. Now let me bring a few capacitors to measure the capacitance. Over here I have a box of salvaged capacitors, and now let's measure some of the capacitors. Let me set it to capacitance mode. As you can see, it's showing some value of 25 nanofarads, but as soon as you connect the capacitors, it will zero down. and show the correct value. Now this is a 4.7 microfarad capacitor, and now just let me hold it over there. Well, this capacitor might be not good. Yes, as you can see, it's bulged a bit. So let's try this capacitor. This should be a good capacitor, and it's 100 microfarad. You need to connect them, and let's see if this is also a good capacitor or not. No, actually, I don't have any good capacitors as far as I think. Hold on, let me bring a few good capacitors. This capacitor is somewhat good. It is 15 microfarad capacitor, and I'm connecting the negative rail to the negative side to the negative probe. There you go, and you will see, yes, it is showing 13.31 microfarads, which is quite close. But let's check this one. As I said, these are all salvage capacitors, and they will not work as far as I know. Will this work? Just hold on, I'm gonna bring a few new capacitors. Here I have a new stockpile of capacitor. First let me put away the old capacitors, and we will check it. So I'm gonna use let's say 47 microfarad capacitor. Let's take one out. Now this is I don't know if you can see it. Focus up, boy. Damn. I do not know why it's not focusing. Just focus on. Yes. Now this is a 4750 volt microfarad capacitor. Now let's turn on the backlight, and let's connect the negative rail to the negative and put positive to the positive side. And there might be some loose connection. Yes. Now we got 52.4 microfarads. That is not that much accurate, but it is somewhat accurate. You can get a referential reading with that. Now let me put back the capacitors. It's all zoomed out, focused out, sorry. Yes, now for the hertz. We know that it can measure frequency, not hold. Now if I just plug it into the AC outlet, it should give me 60 volts, 50 hertz, yes, which is the nominal frequency of our AC outlet, 50 hertz. And then we can go to duty cycle also. It's getting a max value. See, 49.9% duty cycle. And now the non-contact voltage function is pretty simple. Before that, I need to plug out the EM. You just put it in a NCV mode and place it. And when you bring near it outlet, it will start beeping and blinking. As you go further, it won't. Now for the main part, the temperature and this is also already in Celsius. The temperature probe does not require any polarity. Just untwist this. This is a simple temperature probe. Let me just focus in. With this, just connect it to this terminal, just like this, and now it's ready to measure temperature. Let me just focus a bit. So I'm going to use a lighter to see if it can check the temperature. I'm going to set it to max and min. Okay. Wow, it goes up 145 degrees Celsius, 186 degrees Celsius. The more I hold it, the more. Now then change it to min. I think the temperature will fall. Let's set it to auto. Now it is 42 degrees Celsius and the temperature is dropping since I removed the lighter from it. Now we can use the HFE to measure the beta of any transistor, and I hope all of you know how to do that. To measure the beta, you just need to plug the transistor into the collected E for emitter, B for base, C for collector. Like this, you have the NPN side and the PNP side. Now we have the microamps, the milliamps, and the amperage. Now let me see if I can find something to measure the ampere with. Hold on. Over here I have an LM386 audio amplifier circuit which is connected to my audio amplification. And now I'm going to be using these jumpers to connect the positive side. Come here. So we're going to use this jumper over here, and this is the positive coming out. Now to measure the amps, I'm going to set it at microamps, milliamps, because microamps we do not need that for now, because that could be used for basically radio work actually. Not just radio work, a lot of things. Now we're going to set it to the micro and milliamp range, and we're going to plug the black probe into the COM. And before that I need to play some audio, right? Yep. I've took out the output, but as you can see, if I play some music, the amperage is, I hope it's gonna go up. Yes, it depends upon the audio signal actually. So we have getting 5 and 4 milliamps like this, and we do not need the ampere. For the ampere you need a bigger something, for example say a light bulb to measure the AC or DC. And let me disconnect this first. And if you want to convert it to the AC mode, then just press the select button and it's going to go to AC mode. Okay. And if you want to specifically hold one value, let's say, let me plug this into the voltage reading. It's a quite mess right now over here. No. Let's select DC, and where are my ports? This is the positive, and this is the negative. As you can see, it's already measuring 4.94 volts, and if I press hold, it's gonna hold the value over there and it won't change. Even if I remove the probes, it won't change. That is the function of the hold button. So that is going to be, and besides that, so let's have a look inside this meter. The build quality of the meter is awesome, and it's quite a mess over here right now. And you can use this part to hold your probes like this. And it has another hanging probe right over here. The thing which I like about most about this multimeter is that unlike your traditional multimeter, which uses 9 volts, let me open it up. It uses 2 AAA batteries of 1.5 volts. It works on 3 volts. That is quite amazing. Now let me put that back in. The build quality of this multimeter is not disappointing, and for 1500 I am very satisfied with this meter. It's not bad and it's pretty good actually. So, and the rubber casing is also very good. So if you do like this video, please don't forget to like, comment and subscribe, and thank you for watching.